Close your eyes and imagine. You're standing at the edge of a massive canyon, looking down at layers of rock disappearing into the depths below. Each layer is a page in the book of time. Red clay, gray limestone, black shale. Millions of years compressed into just a few meters of stone. And somewhere down there, buried in the deepest layers, there might be a truth hiding that will overturn everything we know about ourselves. A truth that we may not be the first. All our lives we've been told a simple story. First there was an empty planet, then life appeared, simple and primitive. Millions of years of evolution followed, dinosaurs came and went, and finally we arrived. Homo sapiens, the first and only civilization Earth has ever known. We build cities, write books, fly into space. We are the crown of nature's creation, the final chapter in the story of intelligence on this planet. But what if that's not true? What if our story is merely the latest chapter in a book containing thousands of chapters? What if there were others before us? Not just animals, not just creatures driven by instinct, but intelligent species that also built, thought, and created. And what if they vanished so long ago that almost nothing remains of them? It sounds like science fiction, doesn't it? But think for just a moment. Earth is 4.5 billion years old. 4,500 million years. Try to wrap your mind around that number. Can't do it? That's perfectly normal. Our brains simply aren't designed to comprehend such vast stretches of time. We live 70, maybe 80 years if we're fortunate. Even 1,000 years feels like an eternity to us. But 1,000,000 years, 1,000,000,000 years, that exists beyond the boundaries of our understanding. Let's try a different approach. Imagine the entire history of Earth compressed into one calendar year. January 1st at exactly midnight, our planet forms. A molten sphere of superheated rock spinning through the darkness of space. The first few weeks are literal hell. The surface boils, asteroids bombard this young world. Everything around is fire and destruction. Somewhere around late January or early February, the planet begins cooling down. A solid crust forms, rains begin to fall, not ordinary rains but torrents of water lasting thousands of years, filling valleys and depressions, creating the first oceans. And there, in the warm waters of those ancient seas, sometime around March, the first life emerges. Tiny bacteria so simple they barely qualify as living things, but they exist, and this marks the beginning. Months pass by. Life remains simple, single-celled organisms evolving slowly, incredibly slowly. April, May, June, July, August. 8 full months during which almost nothing changes. If you could observe Earth during these months, you'd see nothing but water and bare rock. No plants, no animals. Just endless oceans filled with invisible, microscopic life. Only in September does something interesting start to happen. The first multicellular organisms appear, strange creatures resembling nothing alive today. They swim, they crawl along the ocean floor, they filter water in search of food. By the end of September, life explodes with diversity. This is what scientists call the Cambrian explosion, a sudden appearance of countless new forms of life. October brings the first plants onto land. Green patches begin spreading across the previously barren continents. Insects emerge. Giant millipedes crawl among ancient ferns. In November, dinosaurs arrive. These incredible creatures will dominate the planet for nearly 2 months on our compressed calendar. Just imagine that, 2 complete months of reptilian rule. Then comes December 26th. Suddenly, in a single moment, an asteroid crashes into Earth. The sky goes dark, temperatures plummet, dinosaurs go extinct. Most life on the planet vanishes, but not everything. Small, furry creatures survive. Mammals. They'd been here all along, hiding in the shadows of giants. Now their moment has arrived. December 27th, 28th, 29th. Mammals spread out, evolve, fill the empty ecological spaces. And only on December 31st, on the very last day of the year, do we appear. The first human-like apes emerge around midday. Homo sapiens, our very own species, appears only at 11:37 in the evening, just 23 minutes before midnight. And everything we call civilization, the Egyptian pyramids, the Roman Empire, the Middle Ages, the Industrial Revolution, the Internet, all of this unfolds in the final 11 seconds of the year. 11 seconds. The entire recorded history of humanity fits into the time it takes to count from 1 to 11. Now, with this picture clear in your mind, ask yourself one question. What was happening during all those other 364 days, 23 hours, 59 minutes, and 49 seconds? We're so absolutely certain we know the answer. We're so confident that throughout all this unimaginable expanse of time, intelligence arose only once. Only in us, only in these last fleeting moments. Think about how evolution actually works. It doesn't invent something once and then stop. It experiments again and again and again. Take eyes, for instance. Evolution independently created eyes at least 40 separate times. Insects have one type of eye, we have another. Octopuses have yet a third. And they all developed separately because being able to see provides a survival advantage. Wings appeared repeatedly in insects, in birds, in bats, even in ancient reptiles. Each time nature discovered a new solution to the challenge of flight. So why should intelligence be any different? Why do we assume that the ability to think, to plan, to create is something so utterly unique that it emerged only once in the entire history of the planet? Doesn't that seem remarkably unlikely? Picture the planet 100 million years ago. Dinosaurs still roam here. They've already been ruling Earth for more than 50 million years by this point. Among them exist some truly remarkable creatures. Troodon, for example, a small dinosaur with an unusually large brain relative to its body size. It hunted in coordinated packs, used tactical strategies. Some paleontologists believe that if dinosaurs hadn't gone extinct, Troodon, or its descendants, might have developed even higher intelligence. But let's venture further back in time. 200 million years ago, 300 million. In each of these epochs, thousands upon thousands of different species existed, and every single species had the potential to evolve toward greater intelligence if environmental pressures favored it. Over the course of 300 million years, there could have been dozens, even hundreds of attempts by nature to create intelligence. And here we arrive at the most challenging question of all. If they existed, these other intelligent species, where are their traces? Where are the cities? Where are the tools? Where is anything at all that would tell us, yes, there was a civilization here? The answer lies in understanding what time truly means on a geological scale. Time is the greatest destroyer that has ever existed. It erases everything, slowly, patiently, relentlessly, without exception. Let's take our modern world as an example. Imagine that tomorrow, right at this very moment, all of humanity simply disappears. We just vanish, as though we never existed at all. What would happen to our cities? The first year wouldn't seem particularly dramatic. Buildings would still be standing. Roads would remain in place. Cars would rust but still be recognizable. Plants would start breaking through cracks in the asphalt. Without people to mow lawns and pull weeds, nature would begin its steady return. After 10 years, the picture would change quite dramatically. Roofs would leak. Water would penetrate into buildings. Cycles of freezing and thawing would destroy concrete. Trees would grow straight out of windows. Metal structures would corrode badly. Cities would start resembling ancient ruins. After 100 years, most wooden structures would have completely rotted away. Most metal structures would have rusted through and collapsed. Glass skyscrapers, those iconic symbols of modern civilization, would lie in heaps of shattered fragments. Forests would blanket territories that were once bustling cities. Animals would return, reclaiming spaces from which humans had once pushed them out. 1,000 years later, and almost nothing would remain above the surface. Perhaps here and there, remnants of stone foundations would still protrude. Maybe somewhere in deserts or deep within caves, a few artifacts would be preserved. But mostly, there'd be nothing. Nature would have swallowed everything whole. 10,000 years. Even these last lingering traces would begin disappearing under the relentless action of wind, water, plant growth, freeze-thaw cycles, chemical processes breaking everything down. Stone would crumble, transform into sand. Metal would oxidize completely, become indistinguishable from the surrounding soil. 100,000 years, and from our entire civilization, only the most indestructible materials in the most protected locations would remain. Yes, certain plastics might persist. Yes, somewhere deep underground, metal objects might still exist, transformed into strange mineral formations. But anyone studying Earth 100,000 years from now wouldn't find cities. They wouldn't discover obvious signs that a civilization once existed here. 1 million years. Even these final traces would become almost completely indistinguishable. Plastic would have decomposed into scattered molecules. Concrete would have crumbled to fine dust. Metals would have mixed thoroughly with natural ore deposits. What would be left? A thin layer in the geological record where concentrations of certain elements seem slightly unusual, where the chemical composition of soil shows a strange anomaly, where carbon isotopes behave not quite as expected. A future geologist studying this layer might notice something odd, but would they understand what it actually means? Or would they simply attribute the anomaly to some natural phenomenon, perhaps an unusual volcanic eruption, maybe a rare meteor shower, possibly a strange climate cycle? Now let's add even more time to the equation. Not just 1 million years, but 10, 50, 100 million. Over this immense time span, the continents themselves will be transformed. Mountains that stood tall when our civilization flourished will be completely erased by erosion. New mountains will rise up in their place. Oceans will open and close. Tectonic plates will shift dramatically, plunging entire regions into Earth's mantle where they'll melt down and eventually become part of volcanic activity in some completely different location on the planet. After 100 million years, absolutely nothing will remain of our civilization that could be stumbled upon by chance. No ruins, no artifacts, no obvious telltale signs. Only incredibly subtle, highly specific chemical and geological anomalies that would need to be deliberately searched for by someone who already knew exactly what they were looking for. And this is where the true depth of the problem reveals itself. If we, with all our advanced technology, with our towering skyscrapers and nuclear reactors, with our plastics and sophisticated metal alloys, will leave such a faint trace after 100 million years, how could we possibly expect to find evidence of a civilization that existed 200 million years ago, or 300 million, or even longer? Perhaps they were real. Perhaps civilizations have already risen and fallen on Earth that we will simply never know about. Not because they didn't exist, but because time is far too skilled at keeping its secrets buried. There's one aspect that makes this possibility feel even more plausible. We think about civilization in extremely specific terms. We picture cities built from stone and metal, machines humming with activity, electricity flowing, computers computing. But that's our particular path, the path taken by primates blessed with grasping hands and binocular vision. What if another civilization followed a completely different evolutionary path? Imagine an intelligent species that evolved in the ocean. Dolphins, for instance, already demonstrate remarkably complex social behavior, impressive learning abilities, even the beginnings of what we might call culture. What if, somewhere deep in the past, an oceanic species developed true sapient intelligence? They wouldn't construct buildings because in water that would be essentially meaningless. They wouldn't kindle fires because underwater that's physically impossible. Their technology, if they possessed any, would be utterly different from ours. Perhaps biotechnology, cleverly using living organisms as tools. Perhaps something we literally cannot even imagine with our land-adapted minds. Such a civilization would leave even fewer traces than ours will. And if they existed in an ocean that later disappeared completely due to continental movements, all their traces would now be buried deep under mountain ranges or utterly destroyed by subduction, that geological process where ocean floor gets dragged back down into Earth's mantle. Or imagine a civilization that lived in genuine harmony with its natural environment. Not industrial, not aggressively expansive, but truly sustainable. They used renewable resources exclusively, never polluted the atmosphere, didn't mine metals in enormous quantities. Such a civilization could potentially exist for millions upon millions of years without leaving the kind of crude, obvious geological footprint that we're currently creating. We view the world through the lens of our own limited experience. We naturally think civilization must look essentially like ours does. But this is a fundamentally anthropocentric mistake. Intelligence can take forms we simply cannot imagine, and these radically different forms might leave traces we have no idea how to recognize. The silence of night wraps around you. Stars drift slowly across the sky, following their ancient, predictable paths. And in this profound silence, it becomes easy to feel the true weight of time. Not the time we measure with clocks and calendars, but that deep, deep geological time that flows at the pace of rising mountain ranges and drifting continents. In the year 2018, two scientists published a rather unusual scientific paper. Gavin Schmidt, a climatologist working at NASA, and Adam Frank, an astrophysicist from the University of Rochester, posed a question that sounded almost like pure science fiction, but rested on a genuinely serious scientific foundation. They asked this: if an industrial civilization had existed on Earth millions of years ago, would we actually be able to detect any traces of it today? They named it the Silurian hypothesis, a playful reference to a species of intelligent reptiles from a British science fiction television series. But behind that whimsical name lay an extremely serious thought experiment. These scientists weren't claiming that such a civilization had actually existed. They were asking a purely methodological question. What would the evidence look like if one had? Their conclusions proved simultaneously fascinating and deeply unsettling. Even our own civilization, which has so radically transformed the planet, might become nearly invisible in the geological record after sufficient time has passed. Yes, we're leaving traces behind. Plastic accumulating in the oceans, dramatically altered atmospheric composition, radioactive isotopes scattered from nuclear weapons tests. But how long will these traces actually persist? Plastic degrades. Slowly, extremely slowly, but it does break down. After millions of years, the vast majority of it will have transformed into dispersed organic molecules. Changes in atmospheric composition will gradually smooth out over time through natural processes constantly at work. Radioactive isotopes will steadily decay away. So what actually remains? Perhaps the most enduring trace will be a shift in the isotopic composition of carbon. When we burn fossil fuels like coal, oil, and natural gas, we're releasing into the atmosphere carbon that was buried and locked away millions of years ago. This ancient carbon has a slightly different isotope ratio compared to carbon currently circulating through the biosphere. A sharp change in this ratio will definitely leave a distinct mark in geological layers. If some future geologist millions of years from now carefully studies rock samples from our particular epoch, they might notice this anomaly, a sudden unexplained spike in one specific type of carbon. But what would they think about it? Would they recognize it as a clear sign of industrial civilization? Or would they attribute it to some natural phenomenon, perhaps a massive volcanic event, maybe methane release from ocean floor deposits, something else entirely. The fundamental problem is that nature also creates anomalies all on its own. 56 million years ago, something happened that scientists call the Paleocene-Eocene thermal maximum. The planet's temperature suddenly shot up by 5 to 8 degrees over an incredibly short period by geological standards. Carbon isotopes preserved in rocks from that time period show a dramatic, sharp change. Something released an absolutely enormous amount of carbon into the atmosphere. Most scientists firmly believe these were purely natural causes, probably a massive release of methane from ocean sediments, likely triggered by intense volcanic activity. But could it possibly have been something else entirely? Could it have been an industrial civilization burning fuel at a massive scale, just like we're doing right now? Probably not. But we genuinely cannot exclude it with absolute certainty because we simply have no other evidence to check against. And that's really the core essence of the Silurian hypothesis. It's not actually about whether they truly existed or not. It's about the uncomfortable fact that we cannot be completely certain either way. Our methods for detecting ancient civilizations in the deep past remain far too imperfect. The geological record is frustratingly fragmented. Time has erased far too much evidence. This is quite a humbling thought when you really sit with it. We're accustomed to thinking of science as something that delivers definitive answers to our questions. But sometimes science honestly tells us, we don't know. And perhaps more importantly, we may never know for certain. Some questions lie permanently beyond our ability to answer them conclusively. Not because we're not intelligent enough, but simply because the evidence doesn't preserve itself nearly long enough. But let's continue playing with this intriguing idea a bit further. Suppose, just for a moment, that they actually existed. Suppose that 100 million years ago, or 200, or 300 million, a genuine civilization existed right here on Earth. Not human, obviously. Something entirely different. Perhaps descended from dinosaurs. Perhaps from something even more ancient that we barely understand. What would they have looked like? This is an impossible question to answer definitively, of course, but we can certainly try to imagine. If they were descendants of dinosaurs, perhaps they were reptilian in nature, walking upright on two legs with well-developed forelimbs, perfectly adapted for manipulating objects. Perhaps their skin was covered with protective scales. Perhaps they had large eyes specially adapted for hunting. Perhaps they were cold-blooded, which would mean they depended heavily on external temperature and strongly preferred warm climates. Or maybe they were something completely and utterly different. Some form of life that doesn't even have modern analogs we can point to. What if Earth's long history contained evolutionary experiments that simply never repeated themselves? Forms of organizing matter and energy that arose, flourished brilliantly for a time, then disappeared completely without leaving any descendants behind. If they genuinely reached the level of civilization, they absolutely must have developed language, complex culture, some form of technology. Maybe they learned to control and use fire. Or if they were oceanic creatures, perhaps they developed entirely different methods of manipulating energy. Maybe they constructed cities, not remotely like ours, but structures serving similar fundamental purposes. Places for living, for trading and exchange, for teaching and learning. Maybe they developed science. They studied the stars just as we do. They wondered deeply about the fundamental nature of reality. Maybe they had philosophy, created art, produced literature. Maybe they experienced joy and profound suffering, knew love and devastating loss. Maybe they feared death intensely and searched desperately for meaning in their existence. And then, something went catastrophically wrong. Maybe they faced exactly the same problem we're confronting right now. Climate change triggered by their own industrial activity. Maybe they completely exhausted their planet's finite resources. Maybe they waged terrible wars against each other, and these conflicts became far too destructive to survive. Or maybe it was simply awful luck. An asteroid impact, a super eruption from a massive volcano, a pandemic against which they possessed no defense whatsoever. They died out. every last one of them, and the world simply continued existing without them. Nature steadily returned, patiently filling the space they'd left empty. Their cities slowly crumbled and collapsed, their tools corroded and rusted away, their books, if they even had books, gradually decayed into nothing. Rains washed evidence away, winds scattered remains, time methodically buried everything. And millions upon millions of years later, here we stand, not even remotely suspecting they once walked this same earth. We examine layers of ancient rock and see nothing particularly unusual. We confidently consider ourselves the first and the only. We tell ourselves a comforting story of continuous progress, from simple to complex, from bacteria all the way up to us, from non-intelligent to intelligent. One straight line steadily ascending. But what if history isn't actually a line at all? What if it's a cycle endlessly repeating? Rise, peak, fall, total oblivion, then starting all over again. What if we're not the ultimate pinnacle, but simply another attempt in a long series? Not the grand finale of the story, but merely one of countless paragraphs in an infinitely long book. There's something simultaneously deeply eerie and oddly comforting in this thought. Eerie because it starkly reminds us of our essential fragility. We're not eternal. Our civilization can disappear entirely, and after sufficient time passes, not even a faint memory of it will linger. Future intelligent beings, if any emerge, simply won't know we were ever here. But there's genuine comfort too. It makes us part of something much larger than ourselves. We're not alone in time's vast expanse. Maybe others walked this same path before us. Maybe they too gazed up at these same stars and wondered about their place. Maybe they too loved fiercely, created beauty, nurtured dreams. And though they exist no more, the simple fact that they might have existed somehow connects us to them across the vast chasm of millions of years. Oceans guard secrets far better than land ever could. This is a strange fact, but it's critically important for our story. More than 70% of Earth's entire surface lies covered by water, and most of this water is profoundly deep. The average depth of the ocean measures roughly 4 kilometers. There are places where the floor plunges 11 full kilometers below the surface. We've explored these crushing depths far less thoroughly than you might imagine. The pressure down there is so monumentally enormous that highly specialized equipment is absolutely required just to survive. Light cannot penetrate anywhere near that deep, so eternal darkness reigns. Water temperature hovers near freezing, despite the fact that in certain locations, scalding hot springs burst dramatically from the floor. If a civilization once existed on a continent that was subsequently flooded by rising seas, all its remains would now be resting on the ocean floor, perhaps at a depth of several kilometers, buried under thick layers of accumulated sediment. Would we find them? Extremely unlikely. Even if we accidentally sailed directly over them, our instruments would probably fail to notice anything unusual beneath those heavy layers of mud and sand. But there's an even more intriguing possibility to consider. The ocean floor isn't static at all. It's constantly renewing itself through the ongoing process of plate tectonics. On the ocean floor exist places called mid-ocean ridges, where brand new Earth's crust actively forms from rising magma. This newly formed crust slowly moves away from the ridge, traveling across the ocean floor at a rate of just a few centimeters per year. Eventually, after many millions of years have elapsed, this oceanic crust reaches the edge of a continental plate. And here something truly dramatic occurs. The denser oceanic crust plunges beneath the lighter continental crust, getting dragged inexorably back down into Earth's mantle. This process is called subduction, and it means the ocean floor gets completely recycled roughly every 200 million years or so. Just think carefully about the implications of this. This represents one major reason why searching for traces of ancient civilizations proves so incredibly difficult. Entire regions of the planet, absolutely massive areas of ocean floor. These are places where the past gets literally erased, recycled, utterly destroyed by geological processes operating on vast timescales. And there's yet another factor to consider seriously. Sea levels change dramatically over time. During ice ages, when enormous quantities of water get locked up in massive glacial ice sheets, sea level drops by 100 meters or even more. Continental shelves become exposed, transformed into dry land. During warmer interglacial periods, like the one we're experiencing right now, ice melts rapidly and sea levels rise accordingly. This means coastlines of the past existed in completely different locations than today's shores. Places now submerged 100 meters underwater were dry land just 20,000 years ago. And conversely, locations that once hosted thriving coastal communities now lie completely underwater. Why does this matter so much? Because civilizations absolutely love coastlines. We know this from our own history. Nearly all the great ancient cities were deliberately built close to water, on the shores of rivers, seas, oceans. Water provides abundant food, convenient transportation routes, valuable trading opportunities. If another civilization existed in the distant past, it seems highly likely that their major population centers would also have been located on coastlines. But those ancient coastlines now rest underwater, and the vast majority have never been explored at all. We simply don't know what might be lying down there. Maybe nothing at all. Probably nothing. But maybe, just maybe, something. Sometimes archaeological finds make us pause and truly wonder. Not necessarily definitive proof, but hints, oddities, things that don't fit neatly into our familiar picture. Archaeologists and geologists periodically stumble across something that raises genuine questions. Take, for example, the structure off the coast of Japan's Yonaguni Island. In the mid-1980s, divers discovered an enormous underwater rock formation featuring terraces, steps, right angles, something resembling carved pathways. At first glance, it genuinely looks like ruins of an ancient city, or perhaps a temple complex. Some enthusiastic researchers date it to 10,000 years old, or even older, based on when sea levels were lower and this particular area was dry land. But most geologists strongly disagree with this interpretation. They point out that the rock in this region is layered sandstone, which naturally fractures along parallel lines, creating formations that can easily appear artificial. Right angles, flat surfaces, even features resembling steps, all of these can result from simple erosion and standard geological processes. So what is it really? Nature or genuine ruins? Honestly, nobody knows for absolutely certain. There's no clear evidence of tool marks, no artifacts discovered nearby. But we also cannot completely rule out the possibility of human modification. Maybe it was a natural formation that ancient people slightly modified, adding steps or platforms. Maybe it's entirely a natural phenomenon. There's no definitive answer. Similar mysteries exist in numerous locations. Off the coast of India, in the Gulf of Kambat, sonar equipment detected something resembling geometric structures on the seafloor. Some samples raised from there were dated to thousands of years old. But once again, the evidence remains unconvincing, and most scientists maintain their skepticism. There are reports of strange stone structures on the floor of the Mediterranean Sea, in the Caribbean, off the coasts of various continents. Some are probably completely natural. Some might be remnants of relatively recent human settlements, submerged by rising sea levels after the last ice age ended. But they remind us that oceans conceal their secrets remarkably well. And here's what's truly interesting about this situation. If we find it so tremendously difficult to detect traces of human activity from just a few thousand years ago, under merely a few dozen meters of water, how much harder would it be to find traces of a non-human civilization from millions of years ago beneath kilometers of accumulated sediment? The answer is straightforward. Practically impossible. Without deliberate large-scale searches, which absolutely nobody is conducting because most scientists don't believe there's anything to search for in the first place. But let's approach this question from a different angle entirely. Instead of searching for physical artifacts, which almost certainly haven't survived, what if we look for other types of traces, more subtle perhaps, but potentially far more enduring? Climatologists study ice cores, long cylinders of ice extracted from the massive ice sheets of Antarctica and Greenland. These ice columns contain tiny bubbles of ancient air trapped when snow fell and gradually compressed into solid ice. By carefully analyzing these bubbles, scientists can reconstruct the composition of the atmosphere in the past, how much carbon dioxide existed, what the temperature was, even what pollutants were present. The oldest ice cores extend back roughly 800,000 years. This is an incredibly long time by human standards. You can clearly see cycles of ice ages, periods of warming, periods of cooling. You can observe how concentrations of greenhouse gases changed naturally throughout these cycles. And then, in the most recent layers, you see something dramatically different. A sudden, sharp spike in carbon dioxide and methane, beginning approximately in the 1800s, marking the start of the Industrial Revolution. This is our signature. This represents the unmistakable fingerprint of human civilization in the planet's atmosphere. If another civilization had existed and burned fuel at industrial scales, it would have left a similar, distinctive trace. But here's the fundamental problem. Ice doesn't preserve itself that long. 800,000 years represents the maximum for ice cores. If a civilization existed 2 million years ago, or 10, or 50 million, no ice core from that time period still exists. The ice is far too old. It would have been crushed by pressure, melted away, or simply flowed into the ocean. But there are other kinds of records available. Sediment cores from the ocean floor, for instance. When organisms die in the ocean, their shells sink to the bottom and accumulate gradually, layer upon layer, millimeter by millimeter, millennium after millennium. These accumulated layers contain chemical information about water temperature, about atmospheric composition, about life that existed at that time. By analyzing oxygen isotopes preserved in these shells, scientists can determine past ocean temperatures. By analyzing carbon, they can learn about the carbon cycle, how much carbon existed in the atmosphere, how much in the ocean, how quickly it circulated through the biosphere. And here, we observe some genuinely interesting things. Earth's history is absolutely filled with sudden climate changes, sharp warmings, sharp coolings, periods when the carbon cycle seems to have gone completely haywire, releasing enormous quantities of greenhouse gases into the atmosphere. Most of these events have perfectly reasonable explanations. Volcanic eruptions of truly unimaginable scale, called flood basalts or traps, millions of cubic kilometers of lava erupting over thousands or even millions of years. Release of frozen methane from deposits on the ocean floor, triggered by warming or underwater landslides. Changes in ocean currents that redistribute heat around the planet. But could any of these events possibly have been something else entirely? When you see a sharp spike in carbon dioxide in the record from 56 million years ago, are you absolutely certain it was a natural phenomenon? Or is there the slightest possibility that it was someone burning fuel, altering the atmosphere just as we're doing right now? The problem is that distinguishing between these two scenarios proves essentially impossible. We have no reliable way to say with confidence, this carbon dioxide came from volcanoes, while that carbon dioxide came from an ancient civilization burning coal. Chemically, they're identical, indistinguishable. The only way to know for certain would be to find other evidence of that very civilization that correlates directly with the climate event. But if no such evidence exists, and it probably doesn't, we remain stuck in permanent uncertainty. Some scientists have proposed searching for highly specific chemical signatures. For example, industrial manufacturing creates not just carbon dioxide, but also pollutants, heavy metals, soot, various chemical compounds that don't occur in large concentrations in nature. If you examine sediment layers from our current epoch, you'll find elevated concentrations of lead from burning leaded gasoline. You'll find microscopic plastic particles. You'll find radioactive isotopes from nuclear weapons testing. Cesium-137, strontium-90, plutonium-239. These substances don't exist in nature in significant quantities. They serve as unambiguous markers of technological activity. So, if an ancient civilization had used nuclear power or weapons, we might possibly find traces of long-lived radioactive isotopes in rocks of the appropriate age. If they had mined and processed metals on industrial scales, we might find unusual concentrations of these metals in sediments. The problem, yet again, is that these signals grow progressively weaker over time. Radioactive isotopes decay away. Metals disperse, get diluted, mix thoroughly with natural deposits. After tens or hundreds of millions of years, even these distinctive markers might become completely indistinguishable from background noise. And then there's plastic. We produce truly staggering amounts of plastic, hundreds of millions of tons every single year. Most of it eventually ends up in the environment. Microplastic has now been found absolutely everywhere. In soil, in water, in the air, even inside our own bodies. Plastic is extraordinarily persistent. It doesn't degrade quickly like organic material does. Certain types of plastic can persist for thousands, possibly tens of thousands of years. Over time, it breaks down into progressively smaller fragments, but it doesn't disappear completely. What will happen to all this plastic after millions of years have passed? Some research suggests it might actually become part of the permanent geological record. A thin, distinctive layer, unusually rich in carbon polymers, distinguishable by its chemical structure from natural organic materials. This would serve as a marker, a plastic layer clearly indicating the presence of a technological civilization. But again, the question becomes, how long would this actually persist? Plastic consists of hydrocarbon chains. Over time, under intense pressure and heat, these chains can break apart, rearrange themselves completely. Maybe after 100 million years, the plastic layer would transform into simply a layer rich in certain hydrocarbons that would be extremely difficult to distinguish from other organic deposits. We genuinely don't know for certain. We haven't conducted the experiment. We haven't left plastic lying buried under layers of rock for millions of years just to observe what happens. We can only make educated guesses based on our understanding of chemistry and geology. And this brings us back to the central problem we keep encountering. We're searching for something we've never actually seen before. We're attempting to imagine what evidence would look like for something that may or may not even be real. It's like searching for a needle in a haystack when you don't know what the needle looks like and aren't even certain the needle exists in the first place. But there's one thing we can state with absolute confidence. If we're not actively looking, we definitely won't find anything. Absence of evidence might mean evidence never existed, but it also might simply mean we haven't looked carefully enough in the right places. The silence returns gradually. Stars continue their slow, stately dance across the sky. Somewhere far in the distance, an owl cries out, hunting in the darkness. And you lie here thinking about deep time, about lost civilizations, about the genuine possibility that we're not the first. There's a certain terror in this thought, but there's also a strange kind of beauty. The terror lies in how it reminds us of our essential impermanence. Everything we build, everything we create, everything we love can vanish completely. Not just die, but disappear so thoroughly that even memory itself fades away. Future civilizations, if they emerge, won't know our names. They won't know we existed here at all. But the beauty lies in how it makes the present moment more precious than ever. If everything is temporary, if everything ultimately disappears, then what we do right now matters precisely because this is all we truly have. This moment, this fragile, beautiful present. And there's a connection reaching across time itself. If others existed here before us, if they too gazed at these same stars, asked these same fundamental questions, we're linked to them through those very questions, through the shared sense of wonder, through curiosity, through the attempt to understand. Even if we never learn anything about them, even if no proof is ever discovered, the simple possibility of their existence means something profound. It tells us that intelligence isn't unique to us, that we're part of a broader process, a pattern that the universe creates again and again and again. Stars, planets, life, intelligence. Maybe it's a cycle. Maybe this is what the universe does. And if that's true, then we're not alone. Not just in space, where other civilizations might exist on planets orbiting distant stars, but also in time. Others who came before us on this very planet, and perhaps others who will come after us when we're gone. This is a thought that might comfort you as you drift towards sleep. You're part of a long line of intelligent beings trying to understand their world. Not the first, perhaps, and possibly not the last, but real here and now. And that matters deeply. There exists a strange concept in geology called the stratigraphic signature of humanity. This is the idea that our presence on Earth will leave a distinct marker in the geological record, a layer that future geologists, if they exist, will be able to identify and date as the time of humans. Of course, bones of humans, domesticated animals, perhaps even traces of our buildings if anything exceptionally durable survives. But mostly, it will be chemical and isotopic anomalies. A spike in carbon dioxide levels, the presence of plastic particles scattered everywhere, radioactive isotopes from nuclear weapons testing, elevated concentrations of metals and other pollutants. Some scientists have proposed calling our epoch the Anthropocene, the age of humans, a geological era defined by our impact on the planet. This would be the first time in Earth's entire history that a geological epoch was named after a biological species. But here's an intriguing question. If there was another civilization in the distant past, would it have left a similar layer? Would there be a Dinosaurocene or a Silurocene, or whatever we might call it? And if there was such a layer, would we actually recognize it for what it is? Maybe not, because we're simply not looking for it. When geologists study ancient rock layers, they're searching for natural processes. They interpret what they see through the lens of natural phenomena like volcanism, tectonics, climate cycles. The idea that some anomalies might result from the activities of an ancient civilization isn't even considered, because it's deemed incredibly unlikely. And that's probably correct. The scientific method requires that we start with the simplest explanations and only move to more complex ones if the simple ones fail to work. And usually, simple explanations do work perfectly fine. A strange layer in rock usually has a straightforward geological explanation. An unusual concentration of an element is usually the result of a natural process. But usually doesn't mean always. And if we automatically dismiss the possibility of artificial origins, we might miss something genuinely important. Not because it's likely, but because if it were true, it would completely transform our entire understanding of life's history on Earth. So maybe it's worth at least keeping an open mind. Looking at anomalies not only as puzzles requiring geological explanations, but as possible, highly improbable, yes, but possible indicators of something more unusual. Let's talk about mass extinctions. They've happened again and again throughout Earth's history, as if the planet periodically hits a reset button, wiping out most life and allowing whatever survives to start fresh. The most famous extinction occurred 66 million years ago. An asteroid the size of a mountain slammed into what is now Mexico's Yucatan Peninsula. The energy of the impact equaled billions of nuclear bombs. A shockwave rolled across the planet. Chunks of molten rock were hurled into the atmosphere. Some reached space, then fell back, creating a rain of fire across the entire world. Fires swept across continents. Smoke and ash blocked the sun for months, maybe years. Temperatures plummeted, photosynthesis stopped completely. Plants died in enormous numbers. Herbivores that fed on them died. Predators that hunted the herbivores died. Food chains collapsed worldwide. Dinosaurs, who had ruled the planet for more than 150 million years, disappeared. Not all at once. Some species perhaps survived for years or even decades after the impact, but eventually, one by one, they vanished. By the end, only the smallest, most adaptable creatures survived. Mammals no bigger than rats, birds, some reptiles, and in the oceans, fish, sharks, certain species that could feed on debris and survive in dark, cold water. But this wasn't even the worst extinction. Not even close. 252 million years ago, something far more catastrophic occurred. It's called the Permian-Triassic extinction, or sometimes simply the Great Dying. And the name is well-deserved. 96% of all marine species went extinct. 70% of terrestrial vertebrates vanished. It's the only known mass extinction of insects. When it ended, the planet was nearly empty. Ecosystems had collapsed so completely that it took millions of years for life to recover to its previous level of diversity. What caused this nightmare? Scientists still debate the details, but the basic picture is clear. Massive volcanic activity in Siberia, called the Siberian Traps, erupted lava and gases for nearly 1 million years straight. Carbon dioxide and other greenhouse gases flooded the atmosphere. Temperatures soared, oceans heated up and became acidic. Oxygen in the water became depleted, marine life suffocated. On land, temperatures became unbearable. In the tropics, it may have been too hot for animals to survive at all. Acid rain destroyed vegetation. Ecosystems collapsed one after another like dominoes. And here's what's interesting. This extinction wasn't an instantaneous blow like the asteroid. It was a slow collapse, stretching across hundreds of thousands of years. Species disappeared in waves. Periods of crisis alternated with brief recoveries that were then followed by new crises. It was an agonizingly slow death of the biosphere. Now imagine a civilization existing during such an event. Not necessarily human, something else entirely. They watch their world slowly disintegrate around them. Temperatures rise year after year, crops fail repeatedly. Oceans that once fed them become dead zones. Water sources dry up or become contaminated. They try to adapt naturally. They migrate to cooler regions, toward the poles, into the mountains. They alter their way of life, search for new food sources. Maybe they even understand what's happening if their science is sufficiently advanced. Maybe they try to do something about it. But ultimately, it's too much. The planet changes too rapidly, too dramatically. Even an intelligent species with technology cannot survive when the biosphere itself is collapsing. They die out. Maybe not all at once. Maybe the last populations cling to life in refuges, caves, oases, places where conditions remain tolerable. But eventually even they disappear. And when the crisis finally ends, when the volcanoes quiet down and the climate begins to stabilize, the world is empty, barren, ready for a new chapter of evolution. But of the civilization that was here, nothing remains. Their cities are destroyed by volcanic activity, buried under layers of ash. Their bodies have decomposed, their technology has rusted and crumbled away. After a few million years, new life blankets the planet, and nobody knows they were ever here. This isn't just idle speculation. This is a pattern we observe repeatedly. Mass extinction, then recovery, then a new era of life. It's happened at least 5 times on a major scale and numerous times on a smaller scale. Each time it was an opportunity for a new beginning, but also an end to everything that came before. And here's the question worth asking. If an intelligent species existed before one of these extinctions, how would we know? The very event that killed them would also have buried their traces. Layers of volcanic ash, deposits from floods, new geological formations. All of this would have covered whatever remained of them. By the time future geologists studied those rock layers, all they would see is the extinction itself. Massive loss of species, changes in climate, geological disturbances. They wouldn't be looking for signs of civilization, because why would they? The mass extinction is fully explained by natural processes. But maybe, just maybe, in some cases there was something else. A civilization caught by a catastrophe it couldn't control. or, more disturbingly, a catastrophe it caused itself. Because here's another possibility we must consider seriously. What if some mass extinctions weren't entirely natural? What if an intelligent species, upon reaching a sufficiently high level of technology, could alter its planet so dramatically that it triggered its own extinction and the extinction of most other species? We know this is possible because we're doing it ourselves right now. Our burning of fossil fuels is changing the climate. Our pollution is poisoning ecosystems. Our activities have already caused what some scientists call the sixth mass extinction, the current loss of species at a rate that rivals the great extinctions of the past. If we don't change course, we may create conditions that eventually make the planet uninhabitable for human life. And if we disappear, taking much of the biosphere with us, what will future geologists see? They'll see a mass extinction, a sharp climate change, a layer with unusual chemical properties. But will they know it was a civilization that did this to itself? Or will they think it was just another natural catastrophe? This is a disturbing thought, but it also shows why finding evidence of ancient civilizations is so incredibly difficult. If they existed, and if they disappeared in a mass extinction, their signature would be indistinguishable from the signature of the extinction itself. Geology, climatology, paleontology, all the sciences we use to study the past would interpret the evidence as a natural phenomenon because, well, most of it would be natural. Only extremely careful, highly targeted analysis might detect subtle anomalies hinting at something more. And even then, without direct artifacts to confirm it, it would always remain speculative. But let's step back from catastrophes for a moment and think about something different. Time. The incredible amount of time Earth has had to experiment with life. 4.5 billion years. Let's break this down into more comprehensible chunks. The first half-billion years represent a period of intense bombardment, when the planet was forming and being struck repeatedly by asteroids. Life couldn't exist under these conditions. But around 4 billion years ago, conditions stabilized enough for life to emerge. The first 3 billion years, life was simple. Bacteria, archaea, eventually more complex single-celled organisms. Slow, incredibly slow evolution, but it was happening. Species appeared, adapted, disappeared. Ecosystems developed. Photosynthesis emerged, transforming the atmosphere, filling it with oxygen. Then, about 600 million years ago, everything accelerated. Multicellular life exploded with diversity. Over the next 500 million years, all the major groups of animals we know today appeared, plus many others that went extinct, leaving no descendants. 500 million years. That's an enormous span of time. During these 500 million years, life colonized the land, evolved in every conceivable direction, survived multiple mass extinctions, each time recovering and continuing to experiment. Throughout this time, different groups of animals dominated during different periods. First fish in the oceans, then amphibians on land, then reptiles, then dinosaurs for an incredibly long period, then mammals, and finally, in the very last moment, primates, hominids, humans. Each of these groups had hundreds of millions of years to evolve. Each produced thousands of species, some remarkably complex. And within each group existed the possibility for developing higher intelligence, if evolutionary pressures favored it. Dinosaurs had 150 million years. Some developed complex social behavior. Some showed signs of parental care, built nests, defended territory. Some, like the Troodon mentioned earlier, had relatively large brains. Give evolution another 10 million years, another 20, and who knows what might have developed. Dinosaurs were successful for so long precisely because they were well adapted. But successful adaptation to a stable environment doesn't necessarily lead to developing intelligence. Intelligence evolves when there's pressure to solve problems, to adapt to changing or complex conditions. Maybe somewhere in some branch of dinosaur evolution, during some period of their long dominance, such pressure appeared. Maybe climate change forced some species to adapt faster. Maybe competition between groups became more intense, favoring smarter individuals. Maybe some ecological niche opened up that required problem-solving thinking. And maybe, just maybe, one species made the leap. Not immediately to civilization, of course. Evolution doesn't work that way. But to using tools, to forming social structures, to transmitting knowledge from generation to generation, to the beginning of what we might call culture. This sounds like fantasy, and perhaps it is. But statistically, given the enormous amount of time and the enormous diversity of life, it seems almost strange that this happened only once. That out of all the billions of species that ever lived, only one, ours, developed technological civilization. Maybe we're not the only ones. Maybe we're just the latest. There's one argument against ancient civilizations that seems compelling at first glance. It's the argument from silence. If they existed, we would have found something by now. We dig up the earth constantly for construction, mining, scientific research. We've drilled through ice sheets, taken samples from the ocean floor, studied rocks from every continent, and we've found nothing that definitively points to a civilization before us. This is true. We haven't found anything definitive. But absence of evidence is not evidence of absence, especially when we're talking about timescales of hundreds of millions of years. Let's think about how much of Earth we've actually explored. The planet's surface is enormous, about 510 million square kilometers. Of this, only 29% is land. The rest is ocean, most of which remains poorly explored. On land, large areas are still wild, inaccessible, never studied scientifically. But even if we limit ourselves to areas that have been studied, we're only looking at the surface, literally. Archaeological excavations typically go down a few meters, rarely more than 10 or 20. Geological surveys can go deeper, but they focus on specific formations, specific time periods. A rock layer dating to, say, 100 million years ago might be buried hundreds of meters or even kilometers deep, depending on the region's geological history. To get samples from that layer, you either need to find a place where it's exposed at the surface, which is rare, or drill down to it, which is expensive, and usually only done for specific purposes like searching for oil. So realistically, we've explored only a tiny fraction of the possible locations where traces of an ancient civilization might be found. It's like searching for something lost in a huge city, but only looking in a few buildings, and only on the ground floor. You didn't find it, but does that mean it doesn't exist? Furthermore, we don't really know what to look for. If traces have survived, they won't resemble the ruins of ancient Rome or Egyptian pyramids. They'll be something completely different. Oddities in geological layers, unusual mineral formations, anomalous chemical signatures. And if a geologist isn't specifically looking for signs of ancient civilization, and why would they be? They might see these oddities and simply note them as geological anomalies worth studying, but not as evidence of anything revolutionary. There's another aspect of this puzzle worth discussing: the very nature of intelligence and civilization. We think about them in very specific ways based on our own experience. But what if civilization can look completely different? Our civilization is built on certain principles. We're sedentary, building permanent settlements. We're agricultural, growing food deliberately. We're expansive, constantly expanding, claiming new territories, exploiting new resources. We're technological, creating tools, machines, structures from metal and stone. But this is only one path, one way of organizing an intelligent society. Evolution could have created completely different paths. Imagine a nomadic civilization, a species that constantly migrates, following seasonal resources, never staying in one place long enough to build permanent structures. They could still have complex culture, language, even technology, but technology that's portable, lightweight, possibly made from materials that don't preserve well: wood, leather, bone. Such a civilization wouldn't leave cities for us to find. It wouldn't leave roads. It might leave almost nothing except the bones of the species itself. And if we found those bones, we'd simply classify them as another extinct species, never understanding they were intelligent. Or imagine a symbiotic civilization, a species that developed relationships with other organisms, plants, fungi, bacteria, using them as living tools. Instead of forging metal, they grew trees in specific shapes. Instead of chemical factories, they cultivated microorganisms that produced the substances they needed. Instead of building with stone and concrete, they used bioengineering. Such a civilization would be nearly invisible in the geological record. Their technology would decompose just like any organic matter. The only trace might be an unusual distribution of certain plant or animal species they cultivated. But after millions of years, even that would be indistinguishable. Or take an oceanic civilization, which we've already mentioned. Dolphins and whales already demonstrate remarkable intelligence. They have complex social structures, communicate using sophisticated sounds. Some species even use simple tools. What if in the past, some oceanic species went further? In the ocean, you cannot kindle fire, which means the entire path of development through metallurgy, the Bronze Age, the Iron Age, would be impossible. But there are other paths to complex technology. Acoustics, for example. Using sound for navigation, communication, even for manipulating the environment. Bioluminescence for lighting. Currents and temperature gradients as energy sources. Such a civilization wouldn't build in our understanding of the word. Their cities might simply be gathering places, perhaps marked by arrangements of stones or cultivation of certain coral species. Their technology would be adaptation of natural processes rather than creation of artificial structures. And if such a civilization existed in an ocean that later disappeared or changed due to tectonic processes, which happens frequently over millions of years, any traces would be destroyed by subduction or buried under kilometers of new sediment. The point is that we're looking for civilization that looks like ours. Cities, roads, metals, plastic. But civilization doesn't have to look that way. It can take forms we cannot even imagine based on our limited experience of one type of intelligent life on one planet. This makes the search even more challenging. It's not enough to look for familiar signs. We need to be open to the unfamiliar, to oddities that don't fit expected categories. We need to ask not where are the cities, but what would be the equivalent of cities for a completely different type of civilization? And honestly, we don't know the answer to that question. We don't even know if it's the right question. The night grows deeper around you. Temperature drops slightly. You pull the blanket higher, feeling its warmth, its comforting weight. Somewhere far away, a dog barks, the sound carrying through the silence, then silence returns. In this quiet, it's easy to feel a connection to the past. Not the recent past, not your parents or grandparents, but the deep past, the planet itself. You're lying on an Earth that existed long before you and will exist long after. An Earth that has witnessed the rise and fall of countless life forms. And maybe, just maybe, it has witnessed the rise and fall of other civilizations too. Maybe the rocks beneath you hold secrets we'll never uncover. Maybe history is far richer, far more complex than we think. But even if we never know for certain, the question itself is valuable. It forces us to think differently about time, about life, about our place in the universe. It makes us humble. And at the same time, it fills us with a sense of wonder. Because if they existed, these other civilizations in the deep past, then intelligence isn't unique to us. It's something the universe does, something that arises naturally under the right conditions. And if that's true, then we're part of a broader pattern, a deeper process. And if they didn't exist, if we truly are the first and only, then we're even more special. The only time in 4.5 billion years that matter organized itself into consciousness that can understand itself. The only time the universe opened its eyes and looked at itself. Either way, it's remarkable. Either way, it makes our lives meaningful. Let's talk about one more aspect that's often overlooked: cultural memory. The myths and legends humanity has told itself for thousands of years. Nearly every culture on Earth has stories about previous ages, about worlds that existed before ours. In Greek mythology, as we mentioned, there were the Golden, Silver, Bronze Ages, and the Age of Heroes before our time. Each age ended in catastrophe, and a new one began afresh. In Hindu tradition, time is cyclical, passing through enormous periods called yugas. We're currently in the Kali Yuga, the age of darkness and decline. But before it came other yugas: Dwapara Yuga, Treta Yuga, Satya Yuga. Each previous era was better, more enlightened, and after Kali Yuga ends, the cycle will begin again, returning to a golden age. North American indigenous peoples told stories of several worlds that were created and destroyed before the current one. The Hopi people, for example, speak of 4 worlds. 3 were destroyed due to people's improper behavior. We live in the 4th. The Aztecs believed in 5 suns, 5 successive epochs of creation. Each sun represented a world inhabited by different beings. The 4 previous suns were destroyed by various catastrophes: jaguars, hurricanes, rains of fire, floods. We live under the 5th sun, which, according to prophecy, will also end someday. In Sumerian mythology, one of the oldest written traditions, there were tales of kings who ruled before the Great Flood, who lived tens of thousands of years. After the flood came new kings with more human lifespans. This might simply be a mythological way of saying there was a time before, radically different from the time after. Plato wrote about Atlantis, an advanced civilization that existed 9,000 years before his time and was destroyed by cataclysm in a single day and night. Most scholars consider this a moral parable rather than historical account. But it's interesting that similar stories of lost civilizations appear in various cultures around the world. What should we make of these myths? The scientific approach tells us not to take them literally. They're filled with supernatural elements: gods and monsters, magic and miracles. They reflect the cultural values and fears of the societies that created them, not precise historical records. But there's another way to look at them. Maybe they preserve some distant memory of real events, transformed through multiple retellings into mythic form. Memory of climate catastrophes, of mass extinctions, of times when the world was radically different. Or, more intriguingly, maybe they preserve something deeper. Not memory, but intuition. A sense that people have always had, that the world is older than us, that other things were here before, that we're not the first. This sense might simply be projection of our own mortality onto the world. We know we're born and die, so we imagine worlds are also born and die. We see ruins of ancient civilizations and extrapolate the idea of even more ancient, even more lost civilizations. But maybe this sense points to something real, a pattern in nature that we subconsciously recognize: cyclicality, rise and fall, creation and destruction. These are fundamental processes in the universe, from the lives of stars to ecosystems, from geological cycles to the evolution of species. So why not civilizations? Why should we be the only one, an unrepeatable event in planetary history, rather than part of a cycle that repeated before and might repeat again? Myths don't give us evidence, but they give us perspective. They remind us that people have always asked these questions, always felt there's more to the world's history than we can see or know. And maybe there's wisdom in that. Not wisdom in the specific details of myths, the gods and heroes, the numbers and names, but in the core message: be humble. The world is bigger and older than you can comprehend. Just because you don't know something doesn't mean it's not real. Now let's step back and look at the entire picture again. We've talked about deep time, about geological processes, about mass extinctions, about the difficulty of preserving evidence. We've discussed the different forms civilization might take and the myths that hint at cyclical history. All of this leads to one central point: we cannot know for certain. And that's okay. Science isn't always about knowing. Sometimes it's about understanding the limits of our knowledge. There are questions we can answer. How old is Earth? 4.5 billion years, give or take. How did life evolve? Through natural selection acting on random mutations over enormous periods of time. When did humans appear? About 300,000 years ago in Africa. These are things we know with high confidence, based on extensive evidence from multiple independent sources. But there are other questions we cannot answer. Is life on Earth unique, or is it common in the universe? We don't know. Is the emergence of intelligence inevitable given enough time for evolution, or is it an incredibly rare event? We don't know. Did other civilizations exist on Earth before us? We don't know. And this last question may be impossible to answer definitively. We can say there's no obvious evidence. We can say it seems unlikely based on what we know about evolution and geology. But we cannot say with absolute certainty it never happened. Because absence of evidence in a case where evidence would be unlikely to survive anyway doesn't tell us very much. It's like only searching for your keys under the streetlight because that's where the light is. Even if you lost them somewhere in the darkness, you might not find them under the light. But that doesn't mean they're not out there somewhere in the shadows. So we're left with uncertainty. For some people, this is frustrating. We want answers, certainty, closure. But for others, and I hope for you, this uncertainty is a gift. It means the world is still full of mysteries, that there are questions for the next generation to explore, that we don't know everything and that's okay. That's good. It means there's always more to learn, more to discover, more to wonder about. And in that wonder, there's something deeply human. The ability to look at the world and ask, what if? That's what makes us intelligent. That's what drives science, art, philosophy. Curiosity. The desire to understand. Maybe someday we'll find evidence of an ancient civilization, an undeniable artifact, a chemical signature that cannot be explained otherwise, a structure that's clearly artificial. That would change everything. It would rewrite our history, our understanding of life on Earth. Or maybe we'll never find anything. Maybe the question will remain open forever, and we'll continue asking, wondering, imagining. Either way, the very process of asking is valuable. It expands our minds. It forces us to think in scales of time and space far beyond our daily lives. It connects us to the deep history of our planet, and perhaps to others who might have asked the same questions in the past. There's one thought experiment that might help clarify this entire discussion. Imagine you're a geologist living 100 million years in the future. Humanity has long since disappeared. Maybe a new intelligent species has evolved. Descendants of raccoons, perhaps, or octopuses, or something that doesn't even exist right now. This future geologist is studying Earth's history. They take rock samples, analyze chemical composition, study fossils. They build a picture of how the planet changed over billions of years, and at some point, they reach a layer dating to roughly our time, the early 21st century by the old calendar. What will they see? Will it be obvious that a civilization existed here? It depends on how carefully they look and what they're searching for. If they do standard analysis, they'll notice some oddities. A sudden spike in certain carbon isotopes, unusual concentrations of some metals and rare earth elements, presence of synthetic compounds that don't occur in nature. But will they interpret this as evidence of civilization? Or will they find natural explanations? Maybe this was a period of intense volcanic activity, they might think. Or perhaps an asteroid impact threw unusual materials into the atmosphere. If they dig really deep, if they're extremely thorough, they might find more convincing evidence. Microscopic plastic particles embedded in sediment layers, radioactive isotopes with half-lives and ratios that don't match natural sources. Maybe, if they're very lucky, a fragment of glass or ceramic preserved in a particularly protected environment. But even then, they'd need to make an intellectual leap. They'd need to consider the possibility that these oddities resulted from technological activity. And that's not a natural first conclusion. The natural first conclusion is to look for geological explanations, because geology is what they study. It's their frame of reference. Only if they specifically ask the question, could there have been a civilization here? Only then would they start interpreting evidence in that light. And even then, without direct artifacts, without buildings, without tools, without obvious structures, their colleagues might be skeptical. Interesting hypothesis, they'd say, but not enough evidence for such an extraordinary claim. And they'd be right to be skeptical. Extraordinary claims require extraordinary evidence. But here's the irony. This is exactly what happened. In this scenario, there was a civilization, ours. The future geologist stands on its remains, studies its last traces, but has no way to be completely certain. Now flip the experiment. We're geologists studying layers dating to tens or hundreds of millions of years ago. If a civilization existed then, we're in exactly the same position as the future geologist in our thought experiment. We see oddities, but we lack the context to interpret them correctly. We have no direct artifacts to confirm the hypothesis. So we explain the oddities through geological processes because that's the most obvious explanation. And we're probably right in most cases. But can we be right in all cases? Can we be absolutely certain that none of these anomalies are traces of something more unusual? The honest answer is no, we cannot. And this brings us to an important point about the nature of science. Science isn't about absolute certainty. It's about building the best explanations based on available evidence, while remaining open to new evidence that might change our understanding. Right now, based on everything we know, the most likely explanation is that we're the first technological civilization on Earth. There's no compelling evidence to the contrary. Evolutionary theory suggests that the emergence of our specific type of intelligence, the kind that leads to technology, is a rare event. But most likely doesn't mean definitely true. It means the best explanation we have at the moment. And part of being a good scientist, or just a good thinker, is acknowledging the limits of our knowledge. We don't know everything. We never will. And that's perfectly fine. In fact, it's beautiful, because it means there's always more to learn. Let's talk about something slightly different but related: the Fermi paradox. This is a famous question in the search for extraterrestrial intelligence. If the universe is so huge and so old, why haven't we seen any evidence of other civilizations? Enrico Fermi, a physicist, asked this question in the early 1950s over lunch with colleagues. They were discussing UFOs and the possibilities of alien life, and Fermi suddenly asked, "Where is everybody?" His argument was simple. The Milky Way contains hundreds of billions of stars. Many of them have planets. Some of these planets must be habitable. If even a tiny fraction of habitable planets developed intelligent life, there should be millions of civilizations out there. And some of these civilizations should be older than us, maybe much older. If they developed space travel technology, they could colonize the galaxy in just a few million years, even traveling at fractions of light speed. So where are they? Why haven't we seen their ships, received their signals, found their artifacts? Many solutions to the Fermi paradox have been proposed. Maybe space travel is harder than we think. Maybe intelligent life is extremely rare. Maybe civilizations tend to destroy themselves shortly after reaching technological level. Maybe they're here, but we don't recognize their presence. Maybe they're deliberately avoiding us. But there's another possible solution that connects to our discussion. Maybe civilizations don't last as long as we think. Maybe the period between developing detectable technology and a civilization's disappearance is very short by cosmic standards. Think about our own civilization. We've been broadcasting radio waves into space for only about 100 years. This is the window during which a distant civilization could detect us by intercepting our transmissions. 100 years out of 4.5 billion years of Earth's history. That's 0.000022%.
And how long will we continue broadcasting?
maybe a few more hundred years before we either destroy ourselves or transition to technologies that don't leak as much into space. Let's say a total of 1,000 years of detectability. That's still a tiny fraction of planetary history. If this is typical, if civilizations are usually only detectable for very brief periods of their existence, then the probability of two civilizations being detectable simultaneously becomes very small. The galaxy might be full of planets that had civilizations or will have civilizations, but the chance that two civilizations exist in detectable states at the same time is low. This is sometimes called the "they were here but not now" solution to the Fermi paradox, and it suggests something important. Civilizations are ephemeral. They come and go. The universe is full of ghosts of civilizations that no longer exist, and if this is true on a galactic scale, why wouldn't it be true on a single planet? Why couldn't Earth have its own ghosts of civilizations? Species that achieved intelligence, maybe even technology, but disappeared long ago. This is speculative, of course, but it's consistent with patterns we observe. Life is resilient, but individual species are fragile. Ecosystems can exist for millions of years, but they can also collapse. Stability is temporary. Change is the only constant. So why not civilizations? Why should they be permanent when everything else is temporary? This leads us to think about our own future. If civilizations are ephemeral, if they tend to disappear either through their own actions or external catastrophes, what does this mean for us? It's not necessarily a pessimistic message, though it might seem that way. Yes, it suggests we're not eternal, that our civilization, with all its achievements, might someday vanish like all civilizations before us, if there were any, and after us, if there will be any. But it's also a message about the importance of the present. If we're not eternal, then what we do now matters profoundly. Each generation shapes the future, determines whether civilization continues or ends. We cannot rely on the inevitability of progress or assume everything will be fine automatically. We face serious challenges: climate change, resource depletion, the potential for self-destruction through nuclear weapons or other technologies, social inequality and conflict. These aren't abstract problems, they're real threats to the continuation of our civilization. But we also have something previous civilizations, if they existed, might not have had: awareness. We know about the risks. We can see the slow-motion catastrophes approaching. And that means we can make choices, change course, avoid the worst outcomes. It's not guaranteed. History is full of civilizations that collapsed despite warning signs. The Maya, the Romans, Easter Island. There are many examples of societies that exhausted their resources or failed to adapt to changing conditions. But we're also more interconnected, more informed than any previous civilization in human history. We have global communication, science that can predict the future based on current trends, technology that can help us adapt. If we choose to use these tools wisely, if we choose to work together instead of against each other, we have a chance. Not a guarantee, but a chance. And that's all we ever have. The history of ancient civilizations, real or possible, teaches us humility. We're not invincible. We're not eternal. But it also teaches us resilience. Life continues. After every mass extinction, new species evolve, filling empty niches. After every collapse, new societies rise from the remnants of the old. If our civilization falls, it won't be the end. Life will find a way. Maybe another species will eventually evolve toward intelligence. Maybe millions of years after us, a new civilization will arise, and they'll ask the same questions we're asking. They'll look at rock layers and wonder what came before. And maybe they'll find our traces, or maybe they won't. This isn't a comforting thought for us as individuals or even as a species. We want to survive, to thrive, to continue. But from a broader perspective, from the viewpoint of the planet and life on it, it's simply part of the cycle. Rise and fall, creation and destruction, ending and beginning. And there's a certain beauty in that cycle. Not because death is beautiful, it isn't, but because it gives meaning to life. If everything lasted forever, nothing would matter. It's precisely the impermanence that makes moments precious. You're lying here in this moment, on this night, in this life. And this is a unique moment in the universe's history. There has never been exactly this arrangement of atoms before, this pattern of consciousness, this particular thought in this particular mind. And there never will be again. Millions of years from now, the atoms that make up your body will be part of something else. Maybe rocks, maybe water, maybe other living things. The energy that animates you will pass to other forms. The thoughts filling your mind will dissipate like ripples on a pond. But right now, you're here, alive, breathing, thinking, feeling. Part of this incredible story of life on Earth. An experiment 4 billion years in the making, in organizing matter into ever more complex forms. And that's something remarkable. Out of all the atoms in the universe, out of all possible configurations of matter, you exist. You're one of the few patterns of matter that can be aware of its own existence. Most of the universe is dead rock and gas, cold void between stars. But not here. Here, there's warmth, movement, life. Here, there's thought and feeling. Here, there's you. And as you lie here in the darkness, preparing for sleep, allow yourself to feel gratitude for this. Not religious gratitude to some deity, just quiet acknowledgement of the incredible luck of existence. You might not have been. The chain of events that led to your birth was incredibly improbable. If any of your ancestors had died before reproducing, if any of countless random events had happened slightly differently, you wouldn't be here. But you are. Against all odds, despite all improbability, you exist. And this is a miracle if you allow yourself to see it that way. The same is true for our species as a whole. We might not have emerged. If the asteroid hadn't killed the dinosaurs, if our primate ancestors hadn't survived critical moments, if thousands of other things had happened differently, we wouldn't exist. But we do. We're here. And while we're here, we have the opportunity to experience the beauty of the universe, to understand its laws, to create meaning and purpose. This isn't something to take for granted. This isn't something that will last forever. But while it lasts, it's real and precious. So let these thoughts calm you into sleep. Not thoughts of fear and oblivion, but thoughts of connection and meaning. You're part of an ancient story, a story that began billions of years ago and continues through you. Tomorrow the sun will rise again. The planet will keep turning. Life will continue its dance of evolution and adaptation. And you'll be part of that, contributing to the ongoing story. Were there others before us? We may never know for certain, but the question itself has enriched you. It has expanded your mind, deepened your understanding of time and life. It has connected you to the deep history of the planet you live on. And in the end, maybe that's all we need. Not final answers, but the right questions. Not certainty, but wonder. Not knowing everything, but having the humility to admit how much we don't know. The world is full of mysteries. Some we can solve, others may remain mysteries forever. And that's okay. That's good. It keeps us curious, keeps us searching, keeps us growing. Sleep peacefully beneath the ancient stars. Let the weight of deep time not press down on you, but rock you gently to sleep. Let the thought of lost civilizations not trouble your dreams, but fill them with wonder. You're lying on a planet 4.5 billion years old. Beneath you are layers of history deeper than any ocean. Above you are stars, some of which died long ago, but whose light still travels to you through space. You're a moment between these vastnesses. Small, yes. Temporary, yes. But conscious, aware, capable of asking questions and feeling wonder. And that makes you special. That makes this moment special. Not because it will last forever, but because it's here, now, real and alive. Were there others on Earth before us? Perhaps yes, perhaps no. But you're here now, in this moment. And that's the only thing we can truly know with certainty. The rest is mystery. Beautiful, deep, unsolvable mystery. And may this mystery lull you into deep, peaceful sleep. Good night. May your dreams be filled with ancient worlds and distant stars, with lost civilizations and future possibilities. And when you wake, the world will still be here, patiently waiting, keeping its secrets for one more day. You're part of something ancient and ongoing. Remember that. Cherish it. Live well in the time given to you. And if someday, in some distant future, another species unearths the layers from our time and wonders who we were, may they find evidence of a species that loved, that created, that asked questions, that cared. That would be enough. That would be everything needed. Good night. May deep time rock you to peace.